Hello everyone, welcome back to my YouTube channel. Today I will be teaching about indices. This video will be informative and mostly informative for the students in grade 10, and we will be mainly focusing on secondary level maths. Now let's start our video. Here we have given 7 to the power x. Here x is called a base and x is called a exponent. I will be referring in the upcoming slides and videos for 7 as a base and x as an exponent similarly, so that it will be easier for you to understand and for me to make you understand. Now moving on to solve this equation. Here 7 to the power x is equals to 49. We want some number with base as 7 and power and exponent as some value which will be determined to get the value of x. Here to solve this equation we want a base with 7 and the exponent is something we have to determine. Here as we all know, 7 multiplied by 7 is 49, and which is equals to 7 to the power 2. Here we can get this step from the law of indices. We have that if the base are similar, then the exponent can be equated. Here we get x is equals to 2. For simplification, for understanding, we can get the value for x by cancelling the base on both sides, and here we are left with x is equals to 2. Now moving on to the next question. Here we have 4x to the power 4 to the power x minus 2 is equal to 0.25. Here 0.25 can be written as 25 by 100. 25 times 1 is 25 and 25 times 4 is 100, and here we get 0.25 can be simply written as 1 by 4. And here to convert this 4 in terms of 2, we have 2 to the power 2 is equals to 4, and similarly we can write 1 by 4 as 1 by 2 to the power 2, and this can be similarly written as 2 to the power minus 2. Here let me make you understand how this value converted into this value. Here while changing the place of denominator into numerator, the sign changes. Here we have the denominator, here we have positive sign in the power in the exponent, and if we convert the place of denominator into the numerator, the sign changes. Here we have it 2 to the power negative 2. On the left hand side we have the term 4 to the power minus 2. We similarly have to convert this one into something such that it has the base value of 2 as well. In order to make us easier to equate the left hand side and right hand side term, we are trying to convert the terms so that it has the same base value, which is 2 in this case. In this question 2 to the power 2 is 4, right? X minus 2. Here we can multiply these two terms, these two exponent, which we get is 2 to the power 2 x power minus 2. Now we have simplified the left hand side and right hand side terms, and we are similarly progressed in this step. Now according to the law of indices, if the base values are similar, we can equate the component terms, as we can see in this step. Now we go on to simple arithmetic operation. We will cancel this 2 and this multiplied by 2 we are left with -1. Here we are left with x minus 2 is equals to -1. We can simply simplify this as x is equals to 2 minus 1. Here we have found the value for x, which is 1, where we have finally solved this question. Here in this slide I have been shown to solve the previous question by alternative method. This method is similar to that of the previous one. If you guys don't understand this method, please let me know in the comment section down below. The question says to solve the given equation. To solve this equation, we have to first understand what term we have been given to solve the equation. Here we have given 3 to the power x minus 1 plus 3 to the power x minus 2 plus 3 to the power x minus 3. First we will understand the left hand side terms. Here we have, as we all can see, that here we have given the similar, we can see the common factor on all of these terms, which is 3 to the power x. We have to first separate these terms from that of the other terms so that we can take a common. This first term can be factorized as, can be divided as 3 to the power x multiplied by 3 to the power minus 1, and the second term similarly can be divided as 3 to the power x multiplied by 3 to the power minus 2, and this term can be divided as 3 to the power x power 3 to the power minus 3. Here we have finally simplified the left hand side equations, as we can see in this step. Now let us understand the basic steps. Here 3 to the power minus 1, 3 to the power minus 2 and 3 to the power minus 3. We are left with these three terms as well. Let us understand this. 3 to the power minus 1 can be written as 3 to the power 1 by 3 to the power 1, and 3 to the power minus 2 can be written as 1 by 3 to the power square and 1 by 3 to the power 3. Here 3 means 3 to the power 1 means simply 3, and 3 square means it is 9, and 3 to the 3 cube is 27. Here we all can see that in this step, in the third step of this simplification. Now on the next step, here as I said earlier, 3 to the power x has been taken common from all the other terms, and here we are left with these three terms. On the next step, as indicated in this step, it has taken a LCM. Now I will be explaining to you guys this step. Here we have it 1 by 3 plus 1 by 9. It's a simple LCM, though I am going to explain it to you guys. 1 by 27 here, and the LCM of 3, 9 and 27 will be of course 27. 27 divided by 3 is 9, and 9 multiplied by 1 plus 27 divided by 9 is 3, and 3 goes into the multiplication to 1, and 27 divided by 27 is 1, and 1 multiplied by 1, here we have it, 9 multiplied by 1 is 9, and 3 multiplied by 3 is 3, and 1 multiplied by 1 is 1. Hope you guys understood this step. Here this step simply involves the addition of 9, 3 and 1, which is 13, and on the other step here we can cancel 13 and 13 like this, and this 20. Now on the On the next step, 27 has gone on the right hand side as multiplied by 1. As we all know that 27 is a cube of 3, we need a number with base 3, and here we have it. 27 is equals to 3 to the power 3, and according to law of indices, and as I have indicated in the earlier slides as well, the base here we have the similar base of 3, so that we can equate the exponent component, and we have got our value for x, which is 3. Now let us see this question. This question says us to solve the given equation. Here let us first focus on the right hand side term 2, 1 by 2. It can be written as 2 multiplied by 2, it is 2, right? Okay, plus 1. 2 multiplied by 2 gives a 4 plus 1 gives a 5. Finally we have converted this term into this one, which will make us a lot easier to solve the equation. Now in this question, or in this case, we cannot solve this equation by simply using this 2 to the power x whole time. So we will suppose 2 to the power x is equals to a, and then on the final steps we will finally revert back a into 2 to the power x. Now after supposing 2 to the power x as a, we get this term, this step, and after that we take a LCM of a in the denominator, and we get it a by 1 is a, and a multiplied by 1 plus a divided by a is 1, and 1 multiplied by 1 is equals to 5 by 2. Here a multiplied by it's a, right? A multiplied by a gives a square plus 1 by a is equals to 5 by 2. Now on the next step we will do a crisscross multiplication. 2 will go on multiplication with this factor, and a will go on multiplication with 5. We are left with 2a square plus 1 is equal to 5a. We will now open the bracket, 2a square plus 2 minus, and we will take this right hand side term into the left hand side. Now we have to solve this quadratic equation. 2a square minus 5a plus 2 is equals to 0. For understanding this on how to solve this quadratic equation, first we have to imagine that we have a number such that this 2 will go on a multiplication with this term, this 2, which will give a 4. Here to solve this quadratic equation, we want two numbers such that on multiplication of those two numbers we get a number 4, and on addition of those two numbers we get on multiplication we should get a number 4, and on addition of those two numbers we should get a number 5. Let us go on a hit and try method to identify and to get these two numbers. Let us suppose these two numbers are 4 and 1. 4 and 1 on multiplication gives 4 and 4, and 1 gives 5 on addition. Here we have it, we have our two numbers, which is 4 and 1. Now we can further solve this quadratic equation as follows. As we have already got the two number as 4 and 1, here 2a square minus 4 plus 1. These 4 and 1 are the two identified numbers suitable to solve this quadratic equation. And here now on the next step we open this bracket. On the bracket it becomes negative 4a, and on opening the bracket this positive sign becomes negative, as negative and positive will make a negative. Negative a plus 2 is equals to 0. On next step we take 2a as a common, and we are left with a negative 2 on the bracket, and we will take a negative 1 as a common, and we are left with a negative 2 on the bracket. Or finally we have factorized the quadratic equation as 2a negative 1 multiplied by a minus 2 is equals to 0. Now we have got our two equation as indicated by this step and this one. Here we have got the value for a is equals to 2 and a is equals to 1 by 2. Here 1 by 2 can be written as, here we have 2 to the power 1 can be written as 2 to the power negative 1. Here this question has asked us the value for x, not a, so we will finally, as we have supposed to 2 to the power x is equals to a, we will replace the value of a with 2x as indicated here by this step and by this step. And according to the law of indices, if the base are similar, then the exponent of such equation can be equated. Here we have it, the value for x is plus minus 1, positive 1 and negative 1. In this way we can solve this equation, and we found out the value for x. Now moving on to this problem. Here we are asked to solve this equation. Here at a glance at this problem, it will be easier for us if we have the terms with the exponent having a base of 4. If we convert the terms having the exponent to having a base 4, then it will be much more easier for us to solve this problem. 16 to the power x can be written as 4 to the power 2 multiplied by x, which can be equivalently written as 4 to the power 2x, which can be suggested in this step. And 4 to the power x plus 1 can be written as 4 to the power x multiplied by 4 to the power 1. It will be much more easier for us to solve this problem if we assume a value a for the exponent term 4 to the power x. It will make the calculation and simplification much more easier for us. And at the last, after solving the quadratic equation, we will finally put back on the value for a, which would be 4 to the power x. Now similarly we can get the quadratic equation as this after simple algebraic calculations, as I have already explained on how to solve this quadratic equation. This quadratic equation can be also similarly calculated, and the value for a can be calculated as 4 and 16, similarly as mentioned in this step. If you guys are having trouble understanding this step, please let me know in the comment section. I think you guys will understand these steps for solving quadratic equation and finally obtaining a value for a, which would be 4 and 16 in this case. Now 16, we have got the value for a as 16. 16 can be also written as with a base of 4, and the power would be 2, exponent will be 2. And similarly we put on the value for a as 4 to the power x. Similarly, to calculate the value for x, to obtain the value for x, we have to replace the value for a as 4 to the power x, and solving the equating the value of a with 4 to the power x and similar values of 4 and 16 as we have got the value for a, we can obtain by equating an arithmetic operation, we can obtain the value for x as 1 and 2. Finally, we have solved this problem as well. If you didn't understand how to if you didn't understand to solve the quadratic equation, please let me know in the comment section. This problem is quite different from the others, as it has given us a equation as this one, and we have derived this equation from the given equation. And this the equation that we need to be derived can also be written as 3x cubed plus 9 is equals to 8. Here in this to solve this problem, we are going to use two equations or two formulas, which is a minus b squared is equals to a squared minus 2ab minus b squared. And the other formula would be a minus b cube would be a cube minus 3ab a minus b minus plus b cube. These two formulas we would be using for solving this problem, so you can note it down in your copy, or you can just remember it. Now we first note down the equation that we have been given in the question, and then after the positive 2 on the left hand side will be taken on the left hand side would be taken on to the right hand side. It would be negative 2. As we all know that 3 power 2 by 3 can also be written as 3 to the power 1 by 3 square, and 3 to the power negative 2 by 3 can also be written as 3 to the power negative of 1 by 3 to the power square, as indicated in these steps. And as we also know that this 2 multiplied by 1 will also give a 2, and we will be using the this logic as indicated in this bracket. And 1 is equals to 3 to the power 1 by 3 multiplied by 3 to the power negative 1 by 3, which would also give a 1. We are applying this logic so that we can use the formula for a minus b square. Here in this case, a would be 3 to the power 1 by 3 and b would be 3 to the power negative of 1 by 3, so that we can apply the formula for a minus b squared. This term can be alternatively written as this: a minus b squared, a being 3 to the power 1 by 3 and b being 3 to the power negative of 1 by 3. On the next step, we are supposing that x would be is equals to 3 to the power 1 by 3 minus 3 to the power negative of 1 by 3, so that it would be much more easier for us to solve this problem. Now, as I mentioned earlier, we have to prove and derive this equation. Here we have the term x to the power 3, so we have to take on cubes on both sides of the equation 1, so that it would be easier for us to derive this equation with the cubic power of x. Now, after taking cube on both sides of equation 1, we will apply the formula for a minus b cube here a being 3 to the power 1 by 3 and b being 3 to the power negative of 1 by 3, which would be a cube plus b cube minus 3ab a minus b. Now let us all understand this step. Here this part 3 to the power 1 by 3 minus 3 to the power negative 1 by 3 can be written as x, as we all know the equation 1 can, we can see that the equation 1 has the value for x, which indicates this term. And regarding this term is equals to 1, as 3 to the power 1 by 3 multiplied by 3 to the power 1 negative of 1 by 3 gives 3 to the power 1 by 3 minus 1 by 3. It cancels each other and we are left with 3 to the power 0, and any number having an exponent of 0 is equals to 1, which we can see in this step here. This term is equals to x, and here we have it. We can simply write 3 as it is, rest of the part being same. Now we are left with this equation, x cube is equals to 3 minus 1 by 3 minus 3x. Now we have to simply apply the simple arithmetic operations and LCM and the logic of arithmetic and the logic of LCM. Here 3 would be our LCM. 3 multiplied by 3 would be 9. 3 divided by 3 would be 1. 1 multiplied by 1. Negative of 3 divided by 1 is 3, and 3 multiplied by 3x would be 9x. X cube. Now let us apply cross multiplication. We will get 3x cube is equals to 9 minus 1 minus 9x, and let us move this negative 9x to the left hand side. We will get 9x is equals to 9 minus 1 would be 8, and to match up with this equation, let us take 3x as a common. 3x is 3x x squared plus 3 is equals to 8. In this way we have proved and derived the equation that we are supposed to derive. Thank you so much everyone for watching the video till end. I will be coming up with the similar mathematics tutorials and mathematics contents, so please everyone stay tuned.